Good evening, everyone. Welcome to the tutorial, week 4 tutorial for the NPTEL course, Programming Data Structures and Algorithms in Python. I'm a teaching assistant for this course. So as we doing this in the last tutorial, so we'll choosing some problems and we'll see how we can try to approach them in Python, and if there are any, if I feel that I should tell you any function that I'm using, so we discuss that, and I mean that's how it will go on. So today, first problem that we are going to choose is convert all the digits of a number to respective words. So let us say I have a number 1, 2, 3, 4. So it's a whole number 1234. So we want it to be converted as 1, 2, 3, 4, and so on. If I have any other number, maybe 56, so it should return as 5, 6. So how can we approach this problem? So I mean, as always, we'll check for the validity of the user input. So for this type of uh, problem, we would require a positive integer. So if the user input is not a positive integer, we have to reject that input. And if the user input is valid, then we will start with a base case, because base case is for 0, we want it to return to be as 0. So we'll start from there, and then we'll recursively assign a word to the respective digits. Okay, so that is the approach we are going to follow. But here we need to be careful that if we print the output before the recursive call, we may get the output that we are not even expecting. So we need to be careful, and we'll see what I mean. What I mean from that we need to be careful while printing our output. So here, this is our notebook. So till now, you guys must have been aware that we generally use this deepnote.com. So this is a Jupyter notebook kind of environment. So in this environment, we have respective cells, and we can change the type of cell if we need. So this cell is like a heading cell. So we can control all those things in here. So okay, so our first problem was we wanted to convert all the digits of the given number to a respective word. So if the digit is 1, it should return only 1, and things like that. So first of all, we need to check whether the input provided is integer or not. So, and here one more condition I should have put, that it should be greater than 0 as well. So if the input is not proper, then we are going to return, okay, please provide a valid input, because it's not a valid input for our computation, and a program will terminate at that point. But then we will, if the input provided is proper, then we'll go to our base case, which simply says that if the digit number, I have called it digit num. So basically, if digit num is 0, then it should return 0. Otherwise, it should, otherwise what it should do, now we will start computation of the digits in the given number. So if our number is 1, 2, 3, then n here will n here is like modulo of that number with respect to 10. So if our number is 1, 2, 3, then this modulo will return us 3. Okay, so it is like 1, 2, 3 divided by 10, and the remainder will be 3. And then we will update the number by the floor division. So if we divide 1, 2, 3 by 10, we are going to get because it's a floor division, we are going to get the greatest integer that is available after this after this division. That will be that will be uh, that will be 12 in this case. So our remainder, that is n, is 3, and the digit num that has been updated by floor division with 10 is 12. So if we keep on doing this, so next remainder we are going to get 2, and next number that we are going to get will be 1. And if we further move on, then next remainder will be 1, and digit num, it will go to 0, because if we divide 1 by 10, then the floor division will give us the nearest integer, and the greatest integer, that will be 0. So now I have done two things just to show you that if you do this mistake, your output could be different, and you can try this at home. You can you can just play around with this function. You can change a few things, and you can see what output you are going to get. So I have put print n here just to see what it is going to print if we do print n here, and then we are going to recursively call our digit n, which now has been reduced to, after this operation, it has been reduced to 12, if our number is 1 2 3, so depending upon number. Now we have defined one list here. It is called word list. I have called it word list. So basically, in this word list, I have defined numbers in word format. So it's 0 1 2 3 4 5 6 7 8 and 9. So now after this recursion, I have further printed n. So we will see how this print n returns the output in for both the cases after the recursive call and all. So for now, I will just uh, comment this print n after the recursive call, and we'll move on with this particular print n, and we'll see what output is going to be generated. So in this function, it is doing nothing else, it is just printing n. Fine. So we will see what it is going to do. So here I have called the function. I have given it the digit num 1 2 3 4 5. So as we are looking for n, so it should give some combination of 1 2 3 4 5 or something like that. So we'll see what it is going to return us. So it has returned us 5 4 3 2 1. So if in this case, if I print this, let's see what we are going to get. Okay. So as we are printing after the recursive call, you can say, despite our n is printed as 5 4 3 2 1, our our word list n, so I mean n will be passed here, and respectively we should get our output here. So if we compare these two, if n were 5, as we are getting here, if the output from this recursion, the n is 5, then we should have got our output to be, first output in place of 1, we should have got it to be 5. If it were 4, we should have got 4. So the output, we should have got reversed. But let's see why our output we are not getting as reverse. So you should try this at home. You should print this, portion before this recursive call, and you should see what output you are going to get. So anyways, what I'm going to do is, I have removed the print n before the recursive call, and I am printing this n after the recursive call, and we'll see what output we are going to get. So now you can see the output that we are getting. Okay, just let me block this for now. And the output we are getting as 1 2 3 4 5. So after the recursive call, the output is basically, it stacks up from last to first. So uh, I mean, we should keep this in mind while while doing the operations where the sequence of output matters. So we need to be very careful in that case. So if now, as we are printing our output after the recursive call, we should expect that for the number 1 2 3 4 5, the output should be printed as in words 1 2 3 4 and 5. So after running this, as expected, we are getting output to be 1 2 3 4 5. So if we change our numbers, maybe let us say if we change our numbers to zero point 0.7, so as expected, we have already given a condition that this the input should be an integer. So actually, we have not given a right condition there. So if we change our output to be, let's say, minus of 1 2 3 4 5, then what it is going to do, it is going to give us an output like maximum recursion depth has exceeded. So in your course you must have studied that why this recursion limit has been kept in Python, and the same thing is happening here. Okay, so when you are trying to do this floor division and trying to reach to zero, actually you are never going to reach to zero. So no matter how big your recursion limit is, you are going to face this problem again and again and again. So here we need to be very careful while giving our limiting condition before running this, so that we don't run into these kind of issues and problems. So now we will correct this, and we will run it again, and we'll get what we were expecting: 9 1 2 3 4 5 and 0. So this was a problem where we looked at the recursion, and where we could have faced this problem of recursion limit, where we were mentioned that we should be careful while dealing with recursion, and why the recursion limit has been put in Python. Okay, so our next problem is so this was our first problem, and second problem is we want to convert a dictionary with values as a list to a flat dictionary. So what do we mean by that, and why this is important, we will see. So as I have mentioned here, in real life problems, the memory that is required to store or process the data, it could really be large. So if I mean, so in practice, it's quite wise to store the data in a variable in a manner that it is saved quite efficiently in terms of memory and computation. So now, one example that I am going to show you here, I have created a dictionary. So this is a dictionary where first key is sequence in year, and the sequence is 1 2 3 4, and it will go up to 12. And then second key is month, and in the same sequence we'll have January, February, March, April, May, and June. So basically this key tells us that this January, February, March, April, May, June up to December, they come in sequence 1 2 3 4 5 6 7 8 9 and 9 10 11 and 12. So uh, now, if what we could have done, just to save some storage, what we could have done, we could have rewritten it as uh, first sequence is January, second is February, third is March, and so on. So we could have done this. So this is our motive in this particular problem. We will try to address a dictionary that is written in nested form, and if possible we will try to get it in more memory efficient manner. So it's not like it should always be non-nested. Sometimes there it will be necessary to nest the nest a dictionary. So we will see, I mean, how we should proceed, and when it is needed to nest them. and how we should nest that it should take the least possible memory. So for that, we will use inbuilt functions zip and dict, and we will just simplify our dictionary in that manner. And example for that, we will we'll see in our notebook as always. So yeah. So as you remember, this was the problem from week one. So we, due to limitation of time, we could not discuss this. So, but I have changed this problem a bit so that it addresses the issue we are going to discuss. So here, what we have done is we have defined a function which gives a, if we give it a input, if we give it a input, a integer input as n, then it tells us whether the given year is leap year or a non leap year. Okay, so this problem, I think you must have got the this PowerPoint presentation and this week one notebook. So there, this must have been discussed. So if we if we follow this function, so the as we had discussed even at that time, first of all, as we are going to check whether the input provided is a proper input or not, because it has to be, it has to be an integer first of all. So that we are going to check, and then we are going to apply a condition for a leap year. So for a leap year, the condition should be that the year should be divisible by 4, and if it is a century, it should also be divisible by 400. So what I mean by that is, if let us say we talk about the year 2000, so the year 2000 should not only be divisible by 4 but also be divisible by 400. Okay, which may not be conditioned with 1996. 1996 should only be divisible by 4. If it is divisible by 4, it will be a leap year. So and you can check the back year calendars. The year 1900 was not a leap year because it is not divisible by 400, and the coming year 2100 is also not going to be a leap year. So next century that we can expect to be a leap year is 2400. So other than that, no, none of them is going to be a leap year. So that condition we have applied here, and after applying those conditions, if we try to just check the output of our function, as let us say we want to see whether 1994 was a leap year or a non-leap year. So it was a non-leap year as expected, because 1994 is not divisible by 4. But if we check 1996, it is divisible by 4, and it will be a leap year. 2100, no leap year. And if we say, let us say 2000, it's a leap year and it has just passed. You people must have, I mean, if I mean not just, so it's been some 22 years, but you can easily get to know that it was a leap year. So 2400 was a leap year. So any number that is divisible by 400 in case of century will be a leap year. So now we are going to use this function, and then we are going to flatten our dictionary that has been defined like this. So what this dictionary says, that in case of no non-leap year, number of days are 31, 28. So the key is non-leap year number of days, and the value is a list. So if you can see, value is a list. Okay, so in it, the non-leap year number of days for every month are given 31, 28, 31, and so on. So similarly for second key, that is leap number of days. So that is 31, 29. So you can see, and others are going to remain same. So only thing changes is the number of days in February and the name of a corresponding month. So now it would be a good idea if we could, if we could as here we do not have the respective year. So there could be a possibility we could have we could have a dictionary which has the information of all the years, and it also classifies the leap years and non-leap years, and then it tells us how many number of days in the respective month for that particular year. So for that, what we are going to do is we are going to use our leap no leap function, and we are going to check if if the year if the year that is provided by the user, if it is a leap year as coming out from this function, then then we should recreate a dictionary which should have keys to be the name. So name is the name of the month, and it should have the values as the leap number of days in that particular month. And if it is a no leap year, then it should return us the no leap number of days of that particular month. And if if other than that, if your input is somewhat different than expected, then it should return leap no leap year, because if you remember, if anything else is provided, it is going to return us an error. Okay, so for example, what we are going to do is we are going to run this function, and we will check. So I will just insert a block in here. It should be a code block so we can check. So our function is this. So we will use this function, and we will provide the year. So let us say I'm providing 1996. So it has returned us a dictionary, which it's a simple dictionary. So unlike this one, it's a simple dictionary. It simply says, okay, for this particular year, in February you have 29 days, and for other months it's whatever it should have been. So if we check with 1997 February, we have 28 days, and everything else is same. So, and if we try to give some other value, so let us say we are giving a float value here. So as we have already said that else it should return the output of this function, which should be a warning to the user, and the termination of the program. So it has given us the output, or a warning that we should provide a proper input. Now, I have imported these two libraries here. You must have seen at least system the this sys library, but I have imported one more library. Just we will see why I have imported it, and what purpose could it fulfill for our uh, okay. So here with the list comprehension, I'm going to I'm going to make a list of the years. So uh, just to show you, if I have this, if I run this, so there's a list comprehension. If I run this, and we have already seen, we have even seen the the nested ones in, I think, in our last class. So it has returned us a list of the years from 2000 to 2100. So we have given the range from 2101, so that is why it has given us output up to 2100. So because one is not taken care by this range function. So then what we are going to do, we are going to initialize a dictionary. So in this particular case, what we are doing is we are creating a nested dictionary. Okay, so we are going to use a loop, and we are going to see a nested dictionary, so that we could appreciate the usage of dictionaries and how they are different, and what purpose they can fulfill with respect to their counterpart, which are lists in Python. So because both are mutable, you can change the list by appending or doing some other operations. Similarly, you can change the given list. So we will also see that we at will we can change our list. So we have initialized this list, and then we are just we are giving it a we are providing it a key, and this key should represent another list. So we are providing it a key leap, and it should represent another dictionary. So it should be a dictionary within a dictionary. And then we have given another key, that is no leap. So we had only these two keys, so we do not require any loop for that. So now we have iterated over the year. So this year list, we are going to iterate over this year list. So when we are iterating over this year list, it has the year which could be a leap year, which could be a no leap year. So we'll check that. We'll check whether the year is a leap year or a non-leap year. So if it turns out to be a leap year, now what we are going to do is we are going to update our dictionary with another key. So this key will have all the years that are the leap years. So and this I actually will represent the year information. So as you can see, as the I represents the iterates over the dictionary year. So I is going to represent 2000, 2001, 2002, and so on. So this way we can see that our dictionary can be, our dictionary can have mixed keys. First we are choosing a string key, and then our key we are choosing to be a numeric key. So then we are we are updating this key with this is another list comprehension. So what we are going to do here is, let us say, uh, we are saying that the number of days dot items. So what this dot items actually does, so for that we will just make a code block, and we will see that okay, we have already run this number of days function. Fine. So now this number of days dot items, if we see what it is going to represent actually. So if I is 2000, let us say, then it is going to represent, it is going to provide us within a list we have the tuple, the key and corresponding value. So as expected, as we are, uh, as we want that for the corresponding year, for a corresponding leap year, we should get the number of days in that particular leap year for the respective month. So what we are going to do is we are going to iterate over the number of days I. So I mean the I is going to be iterated from 2000 to 2100. Then we are going to take the items from that I, and we are going to have a tuple, that is key comma val. Okay. So and of course the key comma val was going to be returned by this iteration. I sorry this dot items thing. So you can see that it has returned us key comma value. So that it was going to return. So we have made a list of that. So you can see that the value of this list, which is year days, then with key leap and with key the year, maybe it could be 2000, 2010, 2015, maybe 2100. So corresponding to that, the output we are going to get is a list. So here the value could be a list. Fine. So now, but if leap no leap gives us that this particular year is a no leap year, then we will then we will update this particular key in that dictionary. So in this key we will further update a key, that is, as we have already seen, the year days no leap is a further dictionary. So we should provide key for the dictionary. So this I is representing a dictionary, and we are going to update all the keys and vowels as a tuple in as the value for that dictionary. For corresponding to I, we are going to update the key and val uh, from the number of days dictionary. Okay, and if, as we have already discussed, if uh, if the input is anything else which is not covered by these two, it should prompt us to provide a proper input. So now, what I have done here, then we can print whatever output we are going to get. So first we will see what output we are going to get, and then we will see something else. So if we run this, so as expected, corresponding to key leap, we are expecting another dictionary. So corresponding to key leap, we are expecting another dictionary. So as you know, the curly braces represent a dictionary. So it's a dictionary, so it has the information of all the leap years. So we know 2000 was a leap year, 2004 was a leap year, 2008 was a leap year, 12 was a leap year, 16 was a leap year, and so on. But we already know that 2100 is not going to be a leap year. So last leap year up to 2100 is going to be 2096. And then similarly, it has another key, no leap. Corresponding to no leap, we have the information of all the years that are non leap years. So now, but this could not be a very nice way to have this information, because we know that this is a leap year, but is still corresponding to the year. Every time we are updating this information that, okay, in January we have these many days, in February we have these many days. For 2004, again we are repeating the same thing. Again, it's going to be repetitive. So as you know, the number of years are going to increase, the memory taken by these values are also going to increase. So what we could have done is that we'll see next. So here also uh, we are going to initialize our year. So we had initialized in earlier cell, so we need not to, but still I have done it here. Then we are going to initialize year days dictionary. We are going to provide it a key, and the value corresponding to that key should be a dictionary. This we have already discussed. Now we are going to make a list. So this list should contain the information that whether this first list, I have called it leap year list. So it should contain the information of all the leap years. No leap year list should contain the information of all no leap year. So here what I have done is, I have started an iteration over here, and then I have checked whether it's a leap year or a non-leap year. If it's a non-leap year, sorry, if it's a leap year, then I have updated this dictionary, which was initialized to be empty. Okay, so this is going to be updated again and again up to the output of this stops to be a leap. So then if output is not a leap year, we should check whether it's a no leap year. If it's a no leap year, we should update it in this dictionary. Okay, and if both of the cases are not true, then it should tell us that your output is not right. Then what we need to do is, we need to update our dictionary that was a year days. We should update the key that is leap, as as this was supposed to be, or this was initialized to be a dictionary, so it should have another key. So that key is this dictionary. That key is the key is not the dictionary. Then we have converted this dictionary to a tuple. Okay, and this tuple is actually the new key, and corresponding to the new key, we are going to update the number of days corresponding to a particular month. What else you could have done? You could have, omitted the other months. You could have just updated the February. Okay, this particular year, February will have these many days, and we will know it's a leap year. But anyways, you can improve your program in many ways. But this is just an example we are seeing here. And then we are again going to update this particular key part. So corresponding to key no leap, we had another dictionary. So for that dictionary, we are going to update our key as a tuple of the list no leap year list. So then we are going to update it with a key or key and value of a year that was a non leap year. So if you remember, 2000 was a leap year, so we are updating the key and value with respect to the a leap year, that was 2000. And if it was a non leap year, then we are going to update it with 2100, which was a non leap year. So now we will check the output of this particular function. So we will say year days, and for now I am going to just comment this and we'll run this function. So in this function we can see that as this information 2000, 2004, 2008, 2012, it was also there in other dictionary that we have seen some time back, but it has the value corresponding to that only once. So this value, which was going to be a repetitive, we have decreased the frequency of that particular value to be just once. And similarly for no leap also. So these are all are no leap years, and corresponding to that, we are just saying that for all these no leap years, the corresponding number of days in a month are these many. Okay. So now we are going to check that how much space has been, how much memory has been taken by these two. So first we will simply try to use this function get size of, that we have imported here. It's an inbuilt function in Python. So we have imported this. So we will first check this, what value it produces. So if I'm going to run, we are going to get the value to be 232 bytes. Okay. But if we run this one, let's see what happens. Oh, this one is also giving us 232. So there is something wrong. So what it might have done, in the starting, when you if you check the length of your year days dictionary in both of the cases, so we'll see why it is giving us the same size. So it should be a code. So we'll check. Uh, so year days, we are going to check the length. So uh, length is just 2. And what about here? If we try to check here, first we should run this because the year days should be updated. So now we will check the length here. And as you were expecting, because you have already seen how it was created, the length here is also 2. So this function actually, it has not iterated over the keys. So based upon the outer keys, it has suggested the size of the dictionary, but that may not be true. So what we are going to do is we are going to iterate over the items in the dictionary. So over the keys and the values, we are going to iterate over, and we are going to check the size taken by that. So if we now run this, and we should comment this and we will run this. So as we have already seen, for this dictionary dot items, what it gives us a tuple that is key and value. Okay. So we have made a list of that, and now we are iterating over that list. So to get the size of that particular uh, values corresponding to leap or no leap. So for this particular one, where corresponding to every month, we are rewriting again the number of days in the particular month. So we are getting a size to be 1176 bytes and 2272 bytes. But if we check the same here, it's quite lesser. So what I would suggest is, you need not to be worried about all these functions, inbuilt functions and all, but you need to be careful while you are defining your functions. If we further iterate over, we can see the size of what size it may, if we add the sizes at all the nested levels, we'll get the total size. But it was just to give you an idea that how as intuitively you were expecting that in this case, so which was as intuitively we were expecting that in this case the memory taken should be larger and as compared to this case, and we uh, we have got the same thing when we have checked it with an inbuilt function. So I am telling you again, you need not to worry about all those inbuilt functions, but you need to be careful while writing your codes. And as you move on with your coding skills, you will, if you are careful enough, if you are being careful about all those things, you will see how memory efficient and computational cost efficient these things can be. So okay, so next problem that we are going to choose is, so as every time we choose a problem from statistics, as it is one of the very important as it plays a very important role in data analysis nowadays, and it's a booming area. So we have again chosen one very important statistical parameter, that is called standard deviation. So you must have studied about this maybe in your school level, but we will try to relive this. So let us say you have a data which shows, if you have a large data and by chance it shows a distribution which looks something like this. So this here represents the mean of the data, and about this mean your data is spread in either directions. Okay, now the standard deviation basically tells you about the spread of this data about the mean. So if your sigma is larger, then your spread will be larger, and if your sigma is smaller, then in that case maybe for a smaller sigma your distribution may look something like this. So your spread about the mean is quite small. So it's a very important statistical measure of the spread of the data. So uh, and if you want to read more about this, so I have given this link here. So when you will get this presentation, you can follow this link from qmaths.com and you can learn more about this standard deviation thing. But for the purpose of for the purpose of this tutorial, we have sufficient things that we can move on with. So from the definition of a standard deviation, it should have x bar, which is the mean of the data. So that mean is calculated by this relation. So it's nothing but a simple arithmetic mean. So let us say if our data is x1, x2, x3, and so on, then our arithmetic mean will be, as you know, x1 plus x2 plus x3 plus dot 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 xn divided by n. Okay, so the same thing I have written it in indicial notation form. So I is an indice and we are going to sum over this I. So I can be 1, can be 2, can be 3, can be 4, and it can go up to 1. So the mean of the whole data will be given by this particular relation, and then we are going to use this particular formula. So basically what it tells us, so you will see two formulas for standard deviation. One will use 1 divided by n minus 1, which we are going to use here, and another is going to use 1 divided by n. So don't get confused that one is right and another is wrong. So both serve different purposes. So, but that is out of the scope of this particular talk. So we are not going to discuss that. But if you see, you should not worry about that. So now we will see what this formula represents. So as we can see from initial notation, it should give us it should look something like x1 minus x bar. So x bar is the mean, then we will do the square, then x2 plus x bar, x2 minus x bar, sorry. So x2 minus x bar whole square, then plus, and we will move on up to xn minus x bar whole squared divided by n minus 1. Okay, so as we are using our indice to be small n here, so it has to be small n minus 1. So now, but in this definition, I have used indice to be capital N. So I mean, let's do not get confused by all those things. So it's a simple formula. We are going to, you know, we are going to use this formula. We are going to solve a specific type of problem. So let us say our data that is given, it is in the form of a tuple. So the tuple, which looks like, let us say, which looks like so it's a tuple inside a tuple. So you have a outer level of a tuple, and then in inner level of a tuple, or for, let us say, first element inside the bigger tuple, we have, let us say, a comma a number may be 3. Then second element may be b, and the uh, number may be 8, and and so on. So we can have a tuple like this, and what we want is, for this numeric data we have 3, 8, and and so on. We want the standard deviation of that particular data. Okay, so there can be two approaches. One approach is we deal this like a tuple, and we be careful while indicing, or while indicing, we be careful. If we are not, maybe uh, we can run up in an error or something like that, or we can convert this tuple to a dictionary. So why I am mentioning even this idea of bringing in a dictionary, when we already have a tuple and we can run our program over this tuple. So basically here we will talk about two things. First, we will talk about this standard deviation thing. We have talked about it mathematically. It represents the spread of a data about the mean, and then we will talk about, there are two possibilities. There are a number of possibilities of solving it. So in one possibility we'll solve it as a tuple. In another possibility we will convert this to a dictionary, and then we will approach our problem. So you can look for both the approaches and choose whichever suits you better. So as we have discussed, standard deviation is meaningful only for a numeric data. So second element, basically, of the nested tuple is of importance for us. So basically, it's a tuple inside tuple, so it's a nested tuple. So first element of the outer tuple is this, and for an inner tuple, this is the second element, and this is for importance to us. Then we will be iterating over this particular element inside, to calculate the required statistics. Okay, so and another thing I have mentioned here, as you can see, that there are numerous, um, there are numerous libraries or modules in Python for statistics. They are well established, and you can also use them to calculate many statistics in Python. But as the purpose of this course is not to use the libraries, so we will omit that for now. But as moving on, we will also check what output we are going to get through the library. Okay, so yeah. Okay, so our next problem is, the more important thing in this problem is, our data is given in the form of these tuples. Okay, so uh, we what we are going to, as we have discussed, we could have tried two methods. So in first method, what we are going to do is we are going to convert uh, this tuple to a dictionary. So for that, we are going to use this particular function. So it's a simple function. What we are going to do is we are simply going to say, okay, convert this tuple to dictionary using the inbuilt class dict in Python. And then we are going to okay, so okay, so I think this is a part I were to omit. I forgot. No issues, because here we are not calculating the standard deviation. Let's omit this for now. Okay, so here we have converted our tuple to a dictionary, and then we are defining a function that is going to compute the standard deviation for this particular tuple. So first this tuple, so we are calling this function to convert our tuple to dictionary, and then we are going to calculate the sum of the values in the dictionary. Okay, so if we look at the if we see the dictionary, it should go to the key and it should go to the key value. So we are going to calculate the uh, sum of all the elements in the values for this particular dictionary, and then we are going to divide this summation by the length of the dictionary. So as we have already discussed, that this mean will be the summation of all the values divided by the length of the list, or whatever you have your number stored in. So we have divided by the length of this particular dictionary, and if you see, the dictionary would have length that is equal to, because this is a flat dictionary, it would have same length for the keys and the values. So length of the dictionary is going to return as the length of the keys, which is same as the length of values in this particular case. So we even were not careful, but we have reached to the right, right conclusion or answer. So but while processing all those things, we need to be careful. In case of nested dictionary especially, you need to be careful, because there can be a possibility that the number you are going to divide with length of the dictionary may not be the right number you are looking for. But in this case, it's fine, so no issues. Then we are going to initialize this std. So basically, it's a short for standard deviation. But this in turn will not exactly compute the standard deviation, but it will compute the intermediate values, and then we will use this intermediate value to return the actual standard deviation. So we'll see how we are going to do. So first we are going to iterate over the dictionary values. Then we are, as we have initialized with 0, so we are going to sum it up, and as the iteration progresses, we are going to get the complete summation that we were expecting. Okay, so yeah, so we are going to get this particular summation as we were expecting, and then we are going to divide it by length of the dictionary minus 1, as we have seen in our formula. So we are going to divide it by the length of dictionary minus 1, and then we are going to compute the square root of this whole computation. And this whole formulation is going to return us the standard deviation of this particular uh, I mean the standard deviation of the nested tuple with first second element to be the numeric values in the nested tuple. So then this is how we are going to compute the standard deviation. So now we are going to define our tuple to be let's say a comma 5, b comma 9, c comma 14, and so on, and then we will compute the standard deviation of this particular tuple, so corresponding to this formula that we have already discussed. But in this case we have converted our tuple to a dictionary, and then we have proceed. So if we run this, we are going to get our standard deviation to be 13.83. Okay, so now means about the mean your data is spread by 13.83 on the either side. So now we are going to uh, look at the another approach where we are not going to change the type of the input. So our input was tuple, we are going to keep it that way. We are going to proceed with the tuple. So we have defined another function. So it is std2. So it stands for standard deviation of a tuple. So we have initialized with an average, we have initialized with a standard deviation, and then first we have calculated the average as it was required for the computation of the standard deviation. So that flow must be retained, because if it is not, maybe we are not going to get the expected results. So we have computed our average. So I mean, I have not done anything new. The only thing is I have iterated over the elements of the tuple, and for every element, inside the element, first element actually, second element, which is 0 1, so that's why the indice is 1, but it is the second element that is numeric. So I am updating this average by summing up uh, with with respective numeric value in the tuple element, and then we are going to compute the average. Then, after computing the average, as we have already discussed, we for every element we are taking a difference between element and the average value, and then we are going to square it to get the required summation for a standard deviation, and then we are going to divide it by length of the tuple minus 1 to get the standard deviation. So if we run this one, we are going to get the required value, that is 13.827, which is same as above. If we like to check, now this is an inbuilt library that I'm going to use just to give you the flavor that if with the help of a standard library, sometimes we may not we may not even require to go do all those things. But yes, for learning purpose, you must know how we develop and develop the algorithms and everything, because you cannot start just with the inbuilt functions. Okay, so because many times you may not find the library for your personal requirement, then you may have to develop an algorithm as per your requirement and proceed. But yes, in between, wherever you need, you can use the inbuilt functions as well. So now this is the inbuilt function. So what I have done is I have converted this tuple to a dictionary. Then I have called for the values, dictionary values, and then I have listed those values in a list. Then this is the keyword argument in this particular function. So as you remember, in your formula, we had this number 1 divided by n minus 1. So this DDOF represents this minus 1 part. If you are going to give DDOF as 1, it will compute 1 upon n minus 1 part. If you do not give it as a 1, so it will assume it to be 0, and you will see another formula which will show you 1 upon n, and then next portion. So as we have used the formula to be the summation of the uh, you know summation of the spread about the mean, the summation of the square of the spread about the mean divided by the length of tuple minus 1. So same formula we are going to use here. So we are going to get the same value, as you can see, because the same formula has been used in the standard library as well. But if we change this here, let us say we are not going to even give this part. So this has given us some value which is not same as the value we were expecting. So whatever formula we have used, it has not used the same formula. So by default, it has taken DDOF as 0. So uh, the output, as we were expecting, has come out to be different. So depending upon case to case, you will have to choose the keyword argument in your inbuilt functions. But this is just to give you a flavor that okay, you can use inbuilt functions, but you need to be very careful. You should have a good idea about the function you are going to use, whatever whatever keywords or whatever the variations or varieties of the formula they could have used using those keywords. So you need to be careful about all those things. So if you follow that, it's actually good to go. Now, why I have converted this tuple to a dictionary. So, in real life problems, yeah, there are cases where tuples are necessary. Where you do not want the tuple to be touched or mutated. So there can be cases where you want the tuple to be I mean you want tuple to be applied as a sequence in place of list or dictionary, where you do not want any type of mutation. So let's say in a company you have four founders. So if you want to make eh, and the company owners do not want them to be mutated, so they are not willing to add any more person as a founder or co-founder, or no one wants to leave. So in that case, if we see that okay, defining, I mean, in a sense you can say that that group is a tuple, it's not going to be mutated. So there can be cases in a real life where you can see you can see the requirements of the tuple. And maybe one of the examples we can see where it suits where it suits. But if we convert it to a dictionary, then dictionary can be mutated. So let us say you have this dictionary. So this dictionary, it does not have a key as 2101. So can we do that? So we will see if we can do that. So what we'll do, we'll say year days. So this was our dictionary. So it has a first level of key and the nested key to be okay. So we require our nested key to be 2101. And but yeah, we need to assign it some value. So let us say we are going to assign it an empty list. So we can do that. Now if we check our dictionary, what we are going to get is, yeah, so you can see that this item has appeared. So we have mutated the existing dictionary, but by any means, as as the inbuilt data structures, you cannot mutate the tuples. So as per the requirement, you can see you can use either of the data structure. uh, and you must have seen another aspects of using tuple or list or dictionary in your course.